Welcome back to the deep dive. Today we are standing on the edge of a cliff. A good cliff, hopefully, but a cliff nonetheless. We are continuing our journey through the CPMAI version 7 framework, which is really the methodology that professionalizes the chaos of AI project management.
It really is the antidote to chaos. And today is special because we are finally leaving the creation phase and entering the judgment
All
phase.
right, because we have spent the last few weeks really in the trenches with this stuff. We framed the problem in phase 1, we wrangled and, cleaned all the data in phases 2 and 3. We actually built and trained the algorithms in phase 4. But today we are talking about phase V model evaluation.
This is the moment of truth.
It is, and before we really get into it, I want to set the ground rules for everyone listening, especially our learners out there who are using this to prep for the PMI CPMAI exam. This isn't a quiz show.
No, definitely not.
We aren't going to just rattle off a list of definition flashcards for you.
Because that is not how you learn this material deeply. We're going to treat this as a concept-first conversation. The goal here is to understand the mechanics and the philosophy of Phase V so well that when you see a tricky scenario on the exam, the answer just clicks.
Exactly.
You won't have to memorize it because you will understand the underlying logic behind it.
So let's look at the map for a second. We have a trained model. It sits on a server. It creates outputs. Phase V basically asks the ultimate question, does this thing actually work? But surely it is more nuanced than just asking if it turns on.
Oh, absolutely. I mean, asking if it runs without crashing, that is a software engineering question.
Yeah.
That is very low level. Phase V asks a much bigger question. Does this model fulfill the promises we made to the business way back in Phase I? It is the convergence point.
I really like that term, convergence point. Can you unpack that a little bit?
Sure. Think about the project as a series of distinct threads. Phase I gave us the rules, right? The success criteria, the KPIs, the constraints.
Right.
Then phases 2 and 3 gave us the raw material, the data. Phase 4 gave us the engine, which is the algorithm itself. Phase V is the first time all those threads are tied together in a single knot. It is the very first time the theoretical goals from Phase I collide with the practical reality of what you actually built in Phase 4.
So up until this exact moment, the success criteria were really just words on a page.
Exactly. They were a wish list.
Yeah.
Now they are a scorecard. And honestly, that is why Phase V is terrifying for a lot of data scientists and project managers, because this isn't just a process step, it is a decision point.
I want to drill down on that because you have mentioned before that people frequently misunderstand the word evaluation. They think it just means scanning the results, but you view it as a gate.
It has to be a gate. If you view Phase V as just checking the work, you are implying that the train is going to leave the station no matter what, and you're just looking for typos.
Which is a pretty dangerous way to operate.
It is a disaster mindset. Phase V is a strict binary gate. It determines one of two very specific outcomes.
Up or out.
Up or back. Outcome 1 is that the project is approved to move to Phase 6, which is operationalization. The model goes live. Outcome 2 is that the project triggers a structured iteration loop back to an earlier phase to fix a fundamental problem.
So there is no third option where you say, well, it is kind of broken, but we spent a ton of budget, so let's just launch it anyway and see what happens.
No, that is the sunk cost fallacy. And the sunk cost fallacy is the ultimate enemy of Phase V. The whole job of the CPMAI methodology here is to force you to be objective, to look at the data and say, stop, even if management is screaming at you to go.
That requires a lot of backbone from the project manager. Now, for the students listening, we need to ground this in the official documentation, the PMI Eco, the exam content outline. Where exactly does Phase V live in that document?
This maps directly to CPMAI Methodology Task 6. The official title there is Conducting Model Evaluation and Maintenance.
Task 6. Got it. And does the EQO use the exact same terminology we see in the study guides? Because I know sometimes there is a bit of a translation layer needed between the two.
There is a bit of a shift, yeah. The study guides often use specific labels, like model performance results. But the PMI EQO tends to use these active enablers. So you will see phrases like formulate model evaluation questions or design evaluation plans, and the really big one, address data drift.
So if I'm sitting in the exam center and I see a question about designing an evaluation plan, my brain should immediately lock on to Phase V.
Immediate log. It is all part of the exact same ecosystem. And honestly, designing the plan is a great way to think about it because you really shouldn't be figuring out how to evaluate the model on the exact day you finish training it.
Right, that should have been done ages ago.
Exactly. But Phase V is where you finally execute that plan.
Okay, let's get into the actual machinery of this phase. We have one single task group here, Just one.
Just one, but it is heavy. It is called Evaluate Model Results.
Simple name, incredibly complicated process.
It is the evaluation loop. It is designed to strictly close the development cycle. And I want to warn against a mindset I see in a lot of junior project managers, and frankly, even some senior ones who are just new to AI projects.
What is the mindset?
The rubber stamp mentality. It goes a little something like this. The data scientist comes to your desk and says, hey, the model is done, it looks great, accuracy is super high, and the PM says, great, I trust you, and signs the paperwork to deploy.
I mean, trust is good in a team, isn't it?
Trust is good for friendships. Trust is bad for auditing AI systems. In the CPM AI framework, your job is verification, not just blind trust. You are the gatekeeper.
Right.
If you rubber stamp a bad model, you are personally responsible when it hallucinates or biases against a customer in phase 6.
That is a very sobering thought. So to help us avoid the rubber stamp trap, we're going to break this single task group down. We have 4 specific study concepts that act as our pillars for today's deep dive. Let me just list them out quickly to orient everyone.
Go for it.
Concept 1 is model performance results. Concept 2 is KPI and business outcome validation. Concept 3 is the model iteration approach, which includes the monster topic of drift. And concept 4 is the review process or go, no go assessment.
That is the complete roadmap. If you understand those 4 concepts, and specifically why they have to be separate from each other, you basically understand phase V.
Let's start with concept 1, model performance results. To the uninitiated, this sounds like we are just looking at the scoreboard. Did we win? What does measuring model performance actually mean in this specific context?
This is the strictly technical assessment of the model. We are stripping away the business context for a second and looking purely at the math. We're looking at statistical metrics.
Like what?
Things like accuracy, precision, recall, F1 score mean absolute error. It really depends on whatever metric fits your specific algorithm.
Okay, so we are essentially just looking at the charts and graphs the data scientists produce.
Yes, but, and this is a massive but, you aren't just looking at them in a vacuum. A number implies absolutely nothing without a benchmark.
Context is king.
Right. If I tell you a model has 85% accuracy, is that good?
I mean, it sounds okay, like a B+ student maybe.
Right. But what if it is a model recommending songs on a streaming platform? 85% is amazing.
Oh, for sure.
But what if it is a model detecting a rare, aggressive brain tumor? 85% might be catastrophic negligence. You cannot judge the number without the predefined success criteria from phase I.
Predefined is really the operative keyword there.
It is the only word that matters. And this leads us to the absolute biggest trap in phase V. The exam loves to test this concept. I call it the calibration trap.
The calibration trap, that sounds like a sci-fi thriller. Set the scene for us. How does this happen?
Okay, imagine a scenario. You are the PM for a major bank. You are building an AI to detect fraudulent credit card transactions. In phase I, way back at the start, you sat down with the risk officers and you agreed on a target. You said, for this model to be viable, it must catch 95% of fraud cases. That is your sensitivity target.
Okay, 95%. That is the bar we have to clear.
You wrote it down. Everyone signed it. Now, fast forward 6 months. We are in phase V. The model is trained. You run the evaluation on the test data. The result comes back, and it is 91% sensitivity.
Oof. I mean, close. But it's definitely not 95.
Right. Now, here is where the trap springs. The team looks at that 91% and says, yeah, 91% is actually pretty good.
Yeah, I can see that happening.
I say, it is way better than the old rule-based system we had, which was only catching 80%. Maybe we were just too ambitious with that 95% target. Let's just update the success criteria to 91% and pass the model.
I have to admit, that sounds incredibly tempting. Because you want to ship the product, right? And it literally is an improvement over the old system.
It is incredibly tempting, and it is fatal to your project governance. In the CPM AI framework, that is a massive failure of process. Those success criteria you set in phase I are binding.
So you can't just change the rules.
No. If you simply lower the bar to match the exact arrow you already shot, you are cheating. You are calibrating the target to the result.
So if a team finds themselves in that situation, what is the actual correct move?
You have 2 valid choices. Choice A is that you trigger a formal iteration loop to improve the model until it actually hits that 95% target. Choice B is if you genuinely believe 91% is acceptable now, you must go back to the governance board.
The stakeholders, the sponsors?
Exactly. You formally request a change to the criteria, you explain why, and you get it re-signed. You absolutely do not get to decide that in the privacy of the data science lab.
That distinction is subtle, but so important. It is really all about transparency.
It keeps you honest. Let's look at a higher stakes example just to hammer this home. Think about that AI diagnostic support model we mentioned earlier.
The one helping doctors find diseases.
Right. In Phase I, you define a maximum false negative rate. A false negative in this context means the patient is actually sick, but the AI says they're perfectly healthy.
Which is literally the worst case scenario.
Exactly. If you send that patient home, they might die. So you set a hard, non-negotiable limit. False negatives cannot exceed 1%. In Phase V, if the model comes back with a 3% false negative rate, you cannot say close enough. You cannot launch.
Because close enough in that context means 3 times as many people potentially dying as you originally agreed to risk.
Precisely. So, Concept 1, model performance results, is all about holding the model's feet to the fire against the metrics you agreed upon before you ever started building. No moving the goalposts.
I really love that phrase. We do not change the goalposts.
Yeah.
So let's assume for a moment we survive Concept 1. The fraud model hits the 95%. The diagnostic model hits the 1% safety target. Are we done? Can we finally pop the champagne?
Not even close. You've only proven the model is mathematically sound. Now you have to actually prove it is useful. Which brings us right into Concept 2, KPI and business outcome validation.
Differentiate this for me because I feel like a lot of people, especially non-technical stakeholders, conflate high accuracy with business success.
It is probably the single biggest fallacy in all of AI development. The idea that if I build a smart brain, the business will automatically make money. It is totally incorrect.
Why is that? Why doesn't a smart model just naturally lead to a good business outcome?
Because there is a massive gap between prediction and action. Technical performance just asks, did the model predict the right thing? Business validation asks a harder question. Did the model actually move the business needle?
Did it move the needle? Give me a concrete example where the prediction works flawlessly, but the needle just doesn't move.
Let's look at customer churn. This is kind of the classic textbook example here. You are a subscription company, maybe a streaming service. And obviously, you want to stop people from canceling their subscriptions.
Makes sense.
You build a model to predict who is going to cancel in the next 30 days. You train it. In Phase V, you check the technical performance, so Concept 1, and the model is 98% accurate. It is practically a clairvoyant. It knows exactly who is leaving.
So that is a huge technical success.
Huge. A massive win for the data scientists. Now, you run the business validation, which is Concept 2. This usually involves testing the model in a simulation or maybe a small A/B test with an actual intervention.
Right, because knowing they are leaving doesn't help if you don't do something about it.
Exactly. So your planned intervention is, we are going to send a 10% discount coupon to everyone the model predicts is going to churn.
Sounds like a standard marketing plan.
You run the test, and you quickly find out that nobody stays. They take the coupon, they use it for 1 extra month, and then they cancel anyway. Or maybe they were canceling because the streaming service app is constantly crashing on their TV, so a discount coupon doesn't fix the root cause of their frustration.
So the actual KPI you care about, which is reduce the churn rate, didn't budge at all.
The KPI is completely flat. The model was totally right. They were definitely leaving. But the business solution failed. If you only looked at the accuracy score, you would absolutely deploy this model.
And what happens if you do?
You would spend expensive compute resources running it every single night. You would lose profit margin giving away all these discount coupons, and you would save literally 0 customers in the long run.
That is a money-losing AI.
We call it a zombie model. It walks and talks, but it is entirely dead inside.
So business outcome validation is really checking the utility of the model in the messy, real-world context.
Yes, and mapping this back to the PMI EKO, even though the study label is KPI and business outcome validation, the EKO refers to this under evaluation questions covering business outcomes. It simply asks, does the model deliver value?
This seems like the exact step where the project manager really has to shine and take control. The data scientist cares about the accuracy metric. The PM has to care about the ROI.
Exactly. The PM is the bridge between the lab and the boardroom. You have to ask, okay, the math is beautiful, but are we actually solving the problem we framed in Phase I? If the answer is no, you cannot proceed to operationalization.
Okay, so we have established that we definitely need both technical accuracy and business utility. There are 2 sides of the coin. Now let's go to the dark timeline.
Oh boy.
What happens if we fail? What if the accuracy is only 80% instead of the 95 we needed? Or what if the coupon doesn't actually save the streaming customers?
Then we enter concept 3, the model iteration approach.
This sounds a lot like just going back to the drawing board.
It is, but the how matters immensely here. There is an amateur way to iterate, and there is a professional way to iterate.
Okay, walk me through the amateur way first. What does that look like?
The amateur way is the informal loop. It usually happens entirely inside phase 4. The model isn't learning well, so the data scientist just stays late, tweaks the learning rate, changes the batch size, maybe tries a random forest algorithm instead of a neural net. They just sit there and spin the wheels.
Brute forcing it.
Brute forcing it. Now look,
Yeah.
sometimes that works. But if the problem isn't actually in the hyperparameters, they can spin their wheels for weeks and burn through a ton of cash.
So what is the professional, the CPMAI approved approach?
It is a formal model iteration approach.
Yeah.
This means treating the iteration as a structured, documented decision that requires actual root cause analysis.
Root cause analysis.
Right. You have to identify why the model failed, and crucially, which phase actually contains the original error.
Because the error isn't always in the code.
Rarely is it just the code. Let's trace a failure to see how this works. Suppose your visual recognition model is failing its validation tests. You dig in and find out that the model is constantly confusing cats and dogs.
Okay, a classic classification problem.
You look at the training data, and you find out that the team working back in phase 3, data engineering, was a bit lazy. They used a massive folder of images where 30% of the files were just mislabeled. A picture of a golden retriever was named cat.jpg.
Ah, garbage in, garbage out.
Exactly. Now, if you use the amateur approach, you stay in phase 4 and try to tune the algorithm to somehow handle that massive amount of noise, you are totally wasting your time. You are basically polishing a sneaker when you really need a boot.
I love that analogy.
The formal iteration approach tells you, stop. The root cause is data quality. The solution is to formally go back to phase 3, fix the labels, re-engineer the data set. Then, and only then, do you come back to phase 4 to retrain the algorithm.
So the iteration approach is essentially a diagnostic map that tells you exactly how far back in the life cycle you have to rewind.
Yes, and it prevents that arbitrary, endless backtracking. It saves your budget and your timeline.
Now, you really cannot talk about iteration in phase V without talking about the big one, the word that keeps every AI engineer up at night: drift.
Drift is massive. For the learners taking the exam, consider this a major hotspot. You will see questions on this.
Let's break it down so it is crystal clear. What is drift in plain English?
Drift happens when the reality the model faces in the real world stops matching the reality it studied in the classroom.
The world moves on.
The world is dynamic, but training data is static. That disconnect between the two is drift. The EKO specifically wants you to understand two distinct flavors of this: data drift and model drift, which is also called concept drift.
Let's spar with these one at a time. Data drift first. What is it?
Data drift is when the distribution of the input data changes. The relationship between the input and the output might be exactly the same, but the inputs themselves suddenly look weird or different to the model.
I think we need an example here.
Imagine you train a visual recognition model to process and read corporate invoices. You train it on thousands of crisp, perfect digital PDFs generated by modern accounting software. High contrast, perfect fonts, easy to read.
Super clean data.
The model gets 99% accuracy in the lab, you deploy it, but out in the real world, your actual users aren't uploading pristine PDFs.
What are they doing?
They are taking photos of crumpled paper receipts with their smartphones in a dark, poorly lit bar.
Blurry, heavily shadowed, coffee stains on the paper.
Exactly. The content is still an invoice, the goal is still the same, but the data distribution, the literal pixel values, the contrast, the noise, has shifted completely away from the training set. That is data drift. The model fails because it has literally never seen a dark, blurry invoice before in its life.
Got it. So the inputs themselves have mutated. Now, what is model drift or concept drift?
Yes, concept drift is usually the more academic term you will hear. This one is trickier. This is when the fundamental relationship between the input and the target changes. The world's logic has shifted.
Give me a scenario where the actual logic changes.
Think about a spam filter. If we go back to the year 2010, if an email came in with the subject line, "You have won the lottery," it was 100% spam.
I mean, that still feels like spam to me today.
Sure, but scammers evolve.
Yeah.
In 2025, maybe those lottery filters are just too good. So the scammers pivot. They start using subject lines like "urgent invoice overdue."
Playing on fear instead of greed.
Right. So now, An email with the subject invoice might very well be spam. But back in 2010, an email saying invoice was almost certainly legitimate business correspondence.
So the actual concept of what constitutes spam has drifted over time.
Exactly. The words, the raw data, are exactly the same words in the dictionary. But their meaning regarding the target variable, which is spam versus not spam, has flipped entirely. Another really great example of this is housing prices.
Oh, right, because of inflation and market changes?
Exactly. A real estate model trained on 2019 housing data would look at a three-bedroom house in a certain zip code and predict it costs $300,000. In 2024, that exact same house costs $500,000.
The house itself didn't change at all.
Right. The inputs didn't change. Same number of bedrooms, same square footage, same roof. The concept of its market value changed.
So why is drift specifically a phase V concern? Why are we talking about it here during evaluation instead of waiting until phase the 6 when the model is actually out in the wild?
Because phase V is where you verify if drift has already happened between the time you collected the data in phase 2 and the time you finished training in phase 2. Sometimes projects take a year and the world drifts while you are building.
That makes sense.
But more importantly, phase V is where you design the monitoring plan for drift.
Ah. So part of the evaluation process is asking, do we have a concrete way to detect if this happens in the future?
Correct. If you deploy a model without a drift monitor in place, you are flying completely blind. And here is a major exam pattern for the learners.
Lay it on us.
If you see a scenario question on the test where a model was working perfectly fine but now its performance is suddenly decaying, or the results on the most recent batch of data are poor, the answer is almost always related to drift.
And what would be the wrong answer they might try to trick you with?
The wrong answer is retune the hyperparameters. Do not change the algorithm as your first step. Pick analyze for data or model drift.
That is gold right there. If your car stops running on the highway, check if you ran out of gas, which is drift, before you try to completely rebuild the engine, which is the algorithm.
That is a perfect analogy. Always check the gas first.
Okay, we're really coming down the home stretch now. We have evaluated the technical performance, concept 1. We have validated the business value, concept 2. We have analyzed our iteration paths and checked for drift, concept 3. Now we are standing right at the final gate.
Concept 4. The review process or go-no-go assessment.
Now, I know we had a go-no-go assessment back in phase I. Why do we need another one here?
Because the stakes are astronomically higher now. In phase I, the only real risk was wasting time and some initial budget. In phase V, the risk is actively damaging the business or harming customers. This is the final ultimate gate before the model touches the real world.
I feel like formal is the word of the day today. Why can't we just have a quick team chat on Slack? Hey, the charts look good, let's ship it.
Because informal agreement completely fails the audit test. And it fails the accountability test.
Walk us through the failure mode on that. What happens?
Imagine a project team. They are rushing to meet a hard quarterly deadline. They look at the evaluation charts. Someone says, well, the accuracy is 88%, the target was 90%, but whatever, it's close enough, let's go. Everyone just nods in agreement. They deploy it.
Sounds very efficient, very agile.
Sure, it feels agile right up until 6 months later. The model makes a heavily biased decision that creates a massive PR scandal. Or worse, a regulatory auditor from the EU AI Act walks into your office.
That is a scary knock on the door.
They sit down and they ask, show me the proof that this model met its safety and fairness criteria before you deployed it. Show me exactly who signed off on that 88% exception.
And the team has absolutely nothing to show them.
They have nothing, no record, no signature, just a vague memory of a team chat. That is an unacceptable level of risk for any organization.
So the correct mode, the CPMAI mode as well.
A formal document. The go-no-go assessment presents the formal findings to the project sponsors. It explicitly confirms both the technical performance success and the business outcome success.
It puts everything in black and white.
Yes, and it formally authorizes the transition to phase 6. Or, if it fails, it formally directs a structured iteration.
So it really is the green light required before operationalization can even begin. It is the documentation that says, we did our homework, we checked the math, and we are legally and ethically ready.
Exactly. It is the project manager's shield. If you have that signature, you are protected.
So just to recap phase V, it feels like we have covered a massive amount of ground today.
We really have. We measured the technical stats to make sure the math works. We validated the business value to ensure we aren't deploying a zombie model. We planned our iterations and set up monitors for drift. and we signed off with a highly formal go-no-go assessment.
It is an incredibly comprehensive quality control check.
It is. Phase V accomplishes one main thing when you boil it all down. It provides the confidence and the hard documentation needed to actually operationalize an AI system.
For the PMs listening, the learners who are going to take this test and then go manage real projects, what is the ultimate mindset they should take away from this entire phase?
Do not be the PM who relies on feeling like it looks fine.
Right.
Be the PM who ruthlessly relies on predefined criteria and documented gates. Let the data scientist be the optimist. You have to be the realist.
That rigor is really what separates the absolute pros from the amateurs in this field.
It is. It is the only way to prevent those zombie models we talked about.
Remind us one more time, zombie models.
Models that live in production, eat up your server costs, but provide zero actual business value because no one validated their KPIs. Phase V is designed to kill zombie models before they ever get out of the lab.
I really love that visual. We are all zombie model hunters now.
That's right.
Well, I want to leave our listeners with a final provocative thought as we wrap this up. Think about this as you study. If Phase V does its job perfectly, Phase 6, operationalization, is really just execution. It is just mechanics. But if Phase V is rushed,
Or skipped entirely.
right, if you skip the business validation or you ignore the drift check, Phase 6 isn't just execution, it is a disaster waiting to happen.
You're basically operationalizing a ticking time bomb.
Exactly. Phase V is where you defuse the bomb. Thank you so much for breaking this all down with us today. The depth here was fantastic.
My pleasure. Always happy to talk through the tough parts of the framework.
And for all our learners out there, keep studying, keep questioning the criteria, and we will see you on the next deep dive.